Hello everyone. Welcome to the next lesson on autonomous database. Here we are going to learn about the different workload types that are supported with the autonomous database and also understand some of the key differentiation with respect to handling of the different workload types. Briefly, we'll touch upon some of the key features with respect to performance management when handling these workload types. Typically, an organization will have two kinds of workload that could be transactional or an analytical workload. Each type of workload differs by the way data is stored, retrieved, and accordingly, the performance handling mechanism changes for both. Oracle Autonomous Database is a fully managed database service that is tuned and optimized to handle the different workload types. Autonomous Database primarily supports four different workload types. The first of the type is Autonomous Data Warehouse, abbreviated as ADW, and is designed for analytical workloads. Specifically, it is meant for building your data warehouse, data marts, data lakes, and machine learning workload use cases. The second in the supported workload type is Autonomous Transaction Processing or ATP. It is optimized for transaction processing workload or mixed workloads. Autonomous Transaction Processing Database is very pertinent for high performance complex transaction processing system use cases that may also serve to process analytical workloads in the same database. That's why Autonomous Transaction Processing supports mixed workload as well. The next two workload types supported by Autonomous Database are focused on the developer community. The third workload supported type is Autonomous JSON Database or AJD and is designed for developing JSON-centric applications. Autonomous JSON Database natively stores your JSON documents and you can use NoSQL style APIs to store and retrieve JSON data and build applications that use JSON documents collection. You can also store data other than the JSON collection with a limit of 20 GB. Autonomous JSON Database is based on Autonomous Transaction Processing Database. Hence, when there is a need to store more data than the 20 GB limit, you can promote your Autonomous JSON Database to ATP. The fourth and the last supported workload type is Oracle Apex for application development or the Apex service. It is designed for Apex developers to quickly spin off an Apex service instance and rapidly build and deploy low-code Apex application. It provides browser-based, easy-to-use development environment to load data, manage database objects, and build your application with the rich built-in features which is provided with Apex. Let's take a look into the workload optimization capabilities built into Autonomous Database for the two different workload types. ADW or Autonomous Database optimizes the execution of complex analytical SQLs, whereas Autonomous Transaction Processing or ATP optimizes the transactional queries execution to deliver faster response time and higher throughput. The data storage for each type of workload plays a key role in delivering high performance. Analytical workloads benefit by storing data in columnar format where the interest is only on few columns and not the entire table. ADW, which is optimized for analytical workload, stores those data in columnar format and compressed. This makes data storage more efficient and it enables faster retrieval of only smaller chunks of required columns data to perform the operation and return to end user. And also the database in-memory columnar format uses Exadata flash cache to accelerate the analytical operation. Whereas in ATP, the data is stored in a row format since the transactions are interested on fewer number of rows. In order to retrieve data faster and accurately in ADW, data summaries are created. This takes advantage of the Exadata feature, which creates storage indexes automatically on the disk and in flash to make your scans more accurate by pruning out unnecessary scans. Whereas in ATP, since it is a transactional processing database, data is retrieved faster with the creation of indexes. ATP supports the creation of indexes manually, or you can take advantage of the automatic indexing feature provided with Autonomous Database. Since the data volume in case of data warehouse is very huge, having the entire warehouse data in memory to process them is not feasible. Hence, the majority of memory in Autonomous Data Warehouse is used for improving the performance of the joins and aggregation. Whereas, in case of ATP, since the data is selective in nature, the working set data volume is not so high as in case of ADW. Hence, majority of the memory in ATP is used for caching the data, as this avoids the disk I/O and this makes a significant jump in your query response time. The object statistics is crucial input for Oracle Optimizer to generate an optimal execution plan for your SQL. Hence, it is required that the database has the most recent up-to-date statistics for the tables and indexes in order to render better query response time. In ADW, the statistics are gathered automatically as part of the bulk load operation, and histograms are automatically generated along with that. Whereas in case of ATP, these statistics are updated during the DML operation itself. Let's now briefly discuss about some of the automated capabilities that significantly contributes towards better performance in each of the workload types. Autonomous database controls concurrency and prioritization by defining predefined services in the database, which are otherwise called consumer groups. These consumer groups are used for establishing database connections by your application. Each of these consumer groups is assigned different CPU and IO shares as defined by the resource management rules, which a user connecting to the database can use from the database resources. This share allocation depends on the type of autonomous database workload type. As you can see in the table below, there are 5 different consumer groups. ATP and AJD provides all the 5 different consumer groups, while ADW provides high, medium, and low consumer groups. TP Urgent has the highest priority for critical transaction processing, and it allows you to manually set the parallelism in your application query. High consumer group can use maximum resources, but they provide least concurrency and the queries will run in parallel. Medium consumer group has lesser resources, but they provide higher concurrency compared to the high consumer group. Low consumer group provides highest concurrency and least resources, so queries cannot run in parallel. They are serialized. The priority goes from TP Urgent to low consumer group. The plans shares column depict how much share does one consumer group has over the other. For example, high consumer group can use up to 2 times more resources than medium consumer group and 4 times more resources than low consumer group. The red asterisk indicates what will be the concurrency value depending upon the compute configuration you had chosen during provisioning with autoscale disabled. That is, if you have chosen OCPU based model or eCPU based model. When you enable autoscale with either OCPU based or eCPU based model, then multiply the number by 3 for the consumer group high and medium. Next in the list is the idle time limits. Autonomous database terminates idle sessions that are holding resources for more than 5 minutes in order to make resources available to active sessions that are waiting for the resources. Autonomous database allows you to configure automatic termination of runaway SQL statements that may be running for a longer time. You can set the runtime runaway rules for each of the consumer group to limit the query runtime seconds and amount of IO beyond which the session will get terminated. As mentioned earlier, autonomous database automates creation of indexes and partitions on the tables to make data retrieval faster. It automates gathering of object statistics either during bulk load or during DML operations depending upon the type of workload. It can perform automatic SQL plan management and create SQL tuning sets automatically to detect SQL that have regressed or are consuming significant system resources, and then it can enforce best plans to improve their performance without the need for you to intervene and perform this task manually. All these characteristics make the database an autonomous service on its own. To wrap up on this lesson, we see autonomous database is designed to support the different workload types. It optimizes the configuration to support the different workload types, whether it is transactional workload or analytical workload. Besides that, the resource manager rules enables you to efficient use of the system resources. Depending upon the processing needs of your workload, it allows you to choose the consumer group that provides the necessary concurrency and parallelism as needed for the operation. In short, it has taken a holistic bottom-up approach to provide you a fully managed database system that can manage the different workloads autonomously without you engaging entirely in designing, provisioning, administering, and managing a database system. I believe this gave you some more details on the autonomous database capability in managing the different workload types. Hope this was helpful to you. Thank you. Hello everyone. In this video, you will learn about what different deployment options are available for an autonomous database. This will help you to choose the deployment option that will meet your enterprise requirement. Let's begin. While provisioning and using autonomous database, we need to decide what would be a choice of deployment to meet the continuous business needs. Few factors that one may think of that will drive the decision in choosing the right deployment option. For example, whether it should be accessed over the internet or should the access be limited to your enterprise data center. Do you need to have more control on your database system? It should allow you to customize operational policies, secure the database operations, or do better cost management. Does your organization allow you to store the data outside of your data center, or should it reside within your data center? Do you need only the autonomous database service, or should it be an integrated platform with many cloud native services to meet your overall development and deployment cycle? And of course, cost. You should perform cost assessment in order to decide a mix of one or more deployment options. These are few criteria, but not the complete list. Other could be the country specific data sovereignty laws or the service availability in a region of operation, etc. With Oracle Autonomous Database, you get multiple deployment choice that can suitably address these concerns. The first type of deployment choice is in public cloud. Here you get two options to choose from. First is serverless, which provides easy and fast provisioning of your autonomous database and does not require you to manage any hardware or install any software. Second option is dedicated infrastructure. It gives you higher isolation. You choose the shape of your Exadata infrastructure and it is entirely owned by you, not shared with other customers. You have more control in its operation policy customization and do your own cost management. It is your private database cloud in public cloud. In both these options, the data resides in Oracle data center and has to travel over the internet to and fro between customer data center and Oracle data center. There are scenarios where your organization has to comply with the data sovereignty law of the country, or your organization policy is to store and process data locally within your data center, or you're concerned about the network latency that may occur due to your application being deployed locally and database residing in a far-off data center. These concerns can be easily overcome by using another type of deployment, that is Oracle Autonomous Database on Exadata Cloud Customer. In this deployment, the entire Exadata database service infrastructure runs behind your own data center firewall. Then there is another deployment choice called the dedicated region Cloud Customer. This is the Oracle Cloud Infrastructure public cloud being deployed in your on-premises data center. This brings the complete portfolio of OCI public services into your data center, and this includes Oracle Autonomous Database as well. Now we'll run through some brief explanation about each type of deployments. Starting with serverless, this is the simplest and fastest deployment service with elastic provisioning. Oracle provisions and manages the Exadata infrastructure and the associated software and their periodic updates. The Exadata infrastructure is shared with other customers, but there is no over-provisioning. It ensures higher degree of isolation with Vault integration and does not compromise on the security or performance. You do not have to worry about the maintenance of the database system. All the patches are automatically applied on your database instance in rolling fashion without bringing down the system. You would only have to care about your application level database development and management tasks. There is a minimum commitment with just 1 hour usage and with minimum required compute and storage resources depending on the workload type. You can scale up online instantly as the demand grows. Alternatively, you can enable auto scaling for compute and storage resources. Since this is shared infrastructure, you cannot set any schedule for the various maintenance activity, like you cannot push the date for database updates. However, you would be given an advance notification about the upcoming maintenance activity so that it gives you ample time to plan the database activities of your application. Next, we have Autonomous Database Dedicated Deployment. This is your private database in Oracle Cloud Infrastructure public cloud. It provides more control and isolation of the deployment. It allows you to customize operational policies that align with your organization needs. It runs inside a hardware-enforced virtual cloud network, entirely isolating your deployment from other customers. Once you have provisioned autonomous database in dedicated infrastructure, you can manually scale or auto-scale storage and compute resources, just like the serverless deployment. You do not have to perform any database administration, but you have the advantage of setting a suitable date for applying software updates. You can host both data warehouse and transaction processing workloads in the same deployment. You are required to subscribe to dedicated Exadata infrastructure in OCI, which will be used for your autonomous database deployment. Then we have the autonomous database in Exadata Cloud Customer. This is similar to autonomous database in dedicated infrastructure, but instead of deploying in Oracle Public Cloud, Exadata Database Service Cloud Customer is hosted in your organization data center. Autonomous database is provisioned on Exadata Cloud Customer Gen 2 infrastructure with elastic provisioning capability. This type of deployment addresses various regulations and technical constraints. Example, data sovereignty law, GDPR, industry regulations, data residency requirement, or could be a technical challenge in moving the legacy application to cloud, higher network latency between the application and the database as they are geographically separated by large distance, or your security needs, and then there are application dependency and the complexity in managing those things. This deployment is performed by Oracle and plugged into the network in customer premises, and they also configure the infrastructure to communicate with Oracle Cloud Control Plane. For database backup, you may choose to store locally with NFS storage or to OCI Public Cloud Object Storage or even Zero Data Loss Recovery Appliance. In summary, Oracle Cloud Infrastructure gives you the flexibility to choose the autonomous database deployment based on the user's profile, the kind of control required, and your enterprise need. Irrespective of the deployment type, you get the same fully featured autonomous database that promises of same security, scalability, availability, and performance that overcomes your database management overhead to a very large extent. I hope you have a fair idea of which deployment option to choose when you are going for the deployment of autonomous database in Oracle Cloud Infrastructure. Thanks for watching. Welcome everyone. In this section of the video, we will expand our understanding on the different self-driving capabilities of an autonomous database. Oracle Database self-driving capability automates all the infrastructure and database management activity of the database. This differs from the traditional database management where it involves a lot of human labor and it is more error prone. Oracle Autonomous Database hides all these complexities from you, the maintenance and management involved in a traditional database, by providing you a fully managed database platform for your users so that you can shift your focus more onto application development rather than managing a database. Let's now learn about some of the individual attributes under self-driving. Auto provisioning, as the name implies, will quickly provision an autonomous database for you. You do not have to configure any hardware or install any software in order to provision a database. Based on the compute and storage requirement you specify as inputs, it will quickly provision a pluggable database in a rack-enabled multi-tenant database. It ensures high availability of your database by provisioning it in a rack database on Exadata hardware, which itself is highly fault tolerant. This also allows elasticity by adding more nodes to the cluster and also helps in keeping your database always available during maintenance. It automatically makes the decision as to on which node of the rack cluster should the autonomous database reside. It is enabled in few nodes of the cluster and the database may be open on one or more nodes. Auto provisioning thus instantly provisions a fully managed Oracle database in a platform optimized for your Oracle database. In just few minutes, it automatically sets the underlying platform to keep your database always available, freeing you from all the traditional database management overheads. Hope it was helpful. Thanks for watching. Welcome everyone. Let's learn about the provisioning of autonomous database serverless in this lesson. Serverless provisioning is the simplest and fastest deployment of Oracle database in Oracle Cloud Infrastructure. During provisioning, you have to provide inputs like database name, workload type, compute and storage size, the database version, type of network access, choice of the encryption, and database character set. So once you submit, your database will be provisioned within minutes. The database adopts Oracle Maximum Availability Architecture best practices to keep your database always available. The always on encryption of your data is pre-configured, and the data, whether it is at rest or in motion, is always encrypted. The database ensures highest availability with an SLA of 99.95%. Access to autonomous database is made securely over public internet or using a private endpoint inside the VCN in your OCI tenancy. Connection to autonomous database uses a certification authentication and TCP/IP based connections using TLS 1.2 protocol, thus ensuring a complete end-to-end encrypted communication between the client and the autonomous database. You can enable auto-scaling of compute and storage to meet your dynamic workload requirements. There is a shared responsibility between you as a customer and Oracle. Oracle is responsible for provisioning and managing the database infrastructure. It monitors and manages the entire operation of the database to ensure that the agreed SLA is always met. You as a database owner are responsible for provisioning the database, controlling the access to be granted to end users, manage your application data and the application users. Let's understand some details on the autonomous database resources whose values are provided during provisioning. First is compute, which is the number of CPUs you want to allocate for your autonomous database. Autonomous database right now provides two different compute models that you can choose from. OCPU, this is the legacy pricing model where you specify the number of OCPUs to be allocated for your autonomous database. Then eCPU is the new pricing model that offers a low entry cost with similar or better price performance than OCPU. And eCPU is the default compute model. OCPU is equivalent to one physical core with hyper-threading enabled, while eCPUs is not a physical core or thread. Cores are allocated to your autonomous database from a pool of compute and storage servers. eCPUs provide a consistent pricing metric that is independent of the underlying hardware, like what is the model or the speed of the processor, etc. The minimum number of OCPUs you must provide is 1, while if you use eCPUs, the minimum count is 2. 2 eCPUs cost you lesser than 1 OCPU. When the chosen compute model is OCPU, then it includes the cost of storage to be used for automatic backup. With eCPU model, the cost of the storage used for the backup is charged separately. When you choose OCPUs, automatic backup retention period is fixed to 60 days and this cannot be altered. Whereas with eCPU compute model, you can set the retention period to anything from 1 to 60 days. Auto-scaling of compute is enabled by default during provisioning. If you are not sure of using it, you can disable it by unchecking it. During provisioning, you have to provide values for storage, which will be the reserved base storage for your autonomous database. Allowed values depends on the chosen compute model and the type of workload. For autonomous data warehouse workload type, irrespective of the compute model, you have to specify the size in TB. The minimum size is 1 TB and the maximum size is 384 TB. For an autonomous transaction processing database with OCPU compute model, you can specify the size in TB. The minimum size is 1 TB and the maximum size is 384 TB. If the chosen compute model is eCPU, you can specify the size in GB or TB and the minimum size is 20 GB while the maximum size is 384 TB. Auto-scaling of storage is disabled by default during provisioning and you can enable it by clicking on the checkbox. There are few crucial inputs that you must provide during provisioning. First, selecting the type of network accessibility, that is, how would you like your autonomous database to be accessed. There are 3 different options as you can see in the image. We'll discuss more on this in the next section. Next, choosing the type of encryption for your autonomous database TDE master key. Here you choose whether this encryption should be done using Oracle managed key or you wish to use your own key for encrypting TDE master key that may be in the same tenancy as the database or in a different tenancy. This key is customer managed. And there is a patch level that you can select under maintenance. There are two different patch levels, early and regular. Selecting early patch level will automatically apply the patch 1 week before the actual public release date. And selecting regular patch level will apply the patch automatically once it is released publicly. Usually, if you have a test instance, you can choose patch level as early so that you can fully validate your application for any incompatibilities and have them fixed by raising a service request. This can be done before the patch is applied to production environment. Now let's take a look into the different network access options available with Autonomous Database Serverless. Firstly, secure access from everywhere. This means your Autonomous Database can be securely accessed over the internet by the client. This is the default option. This option assigns public endpoint, public IP, and a hostname to the Autonomous Database. Autonomous Database uses mutual TLS authentication by default. It requires both the client and Autonomous Database to authenticate each other using a certificate. Certification authentication uses an encrypted key that is stored in a wallet file or the client credential file. You must download the wallet file from the Autonomous Database details page onto the client machine, which will connect to your Autonomous Database. During connection establishment, the key on the client is matched with the key on Autonomous Database server in order to authenticate and establish connection. Client connections to Autonomous Database are TCP/IP connection using standard TLS 1.2 that provide complete end-to-end encryption and it cannot be intercepted. Second is secure access from allowed IPs and VCNs only. With this option, though the database has a public endpoint, but it cannot be accessed by all clients over the internet. Access is limited only to whitelisted IPs you define in the access control list or only to those VCNs for which the security rules have been defined. Third type is the private endpoint access only. This option is preferred when your database holds critical data and the access should be highly restricted. This option assigns a private endpoint, private IP, and hostname to your database. It allows traffic only from the VCN you specify during provisioning and restricts access from all public IPs and VCNs. You control access to the database by defining ingress and egress security rules at the network security group level in the VCN. Here let's discuss about the client connections, the modes and the types with Autonomous Database Serverless. Client connections in Autonomous Database are established over secure TCP and these connections are secured using TLS 1.2 security standards which ensures the data is encrypted throughout the transit to and fro between the database and the clients. Oracle Autonomous Database uses a self-signed certificate for authentication. This is available for you to download, which we referred earlier as the wallet or the credential file. Oracle Autonomous Database supports two different types of authentication, MTLS or TLS, and it depends on the type of network access you have chosen. If you have chosen secure access from everywhere, then it enforces MTLS-based authentication. If you choose secure access from allowed IPs and VCNs only, then you can use both MTLS or TLS. You can restrict access to the MTLS method only by keeping the checkbox required mutual TLS MTLS authentication ticked in the console, which is the default setting. It's the same behavior if you choose private endpoint access only, where you can use both MTLS or TLS or restrict to use MTLS method by keeping the default setting. Unchecking the box allows you to use either of these two authentication methods. The supported connection drivers include JDBC Thin driver, JDBC OCI, OCI, ODBC, Python Oracle DB. For MTLS-based connections, you must download the credential file into the client machine and set the configuration before you can connect to the Autonomous Database. For TLS-based connection, you do not need a wallet file, but as a network access prerequisite, you must either define an access control list or a private endpoint must be configured for your database. Whether you choose MTLS or TLS-based connections in Autonomous Database, both modes provide encrypted communication between the client and the Autonomous Database. To conclude on this lesson, Oracle Autonomous Database Serverless makes provisioning much faster and simpler. Few basic inputs. It is provisioned in minutes and you can easily establish a secure database connection even in public cloud. Through the different network access configuration, you can add more restriction as to who all can access the database. Irrespective of the workload type, you can expand your resources online to a large size as the demand grows, and this can be automatic or on a need basis. Encryption is always on by default. That means data is always protected whether it is being accessed over public internet or over a private connection. There is no database management overhead that you should be worried about after provisioning the database, as everything will be automatically managed on your behalf. You can focus more on the development task using the database. I believe with this understanding, you would be in a good position to provision autonomous database serverless in your tenancy. Hope it was good learning. Thanks for watching.
Hello everyone. Let's see a demo on provisioning of autonomous database serverless in Oracle Cloud Infrastructure. We are into the landing page of Oracle Cloud Infrastructure. First, you must select your subscribed OCI region. Here we have selected US East Ashburn. On the left, here is the navigation menu. Click on the navigation menu and scroll below to Oracle Database. And here you see all the list of services which are related to Oracle Database. Let's provision Autonomous Transaction Processing Database. Click on Autonomous Transaction Processing. So this is the page where you see all the list of Autonomous Database which has been provisioned. And in the left, you can select your compartment where you want to provision. Click on Create Autonomous Database. So this is the page where you have to fill the details about your autonomous database. A compartment is already pre-selected. So provide a display name. Let's put, and same for the database name. Scroll below and here you see the different workload types. We have data warehouse, transaction processing, JSON and Apex. So since we had selected transaction processing workload type, it is already pre-selected. And then we have the different deployment types. One is serverless and then dedicated. Serverless is the default one, so it's already selected. Now let's check into the configure the database section. You can choose the database version. Right now we have only 19C, so showing the default. And here what you see is the eCPU. If you have gone through the lesson, you might have seen already we talked about the different compute models. eCPU is one of the compute model. The minimum number of CPUs what you need to provide is 2. And right, you see there is a compute auto scaling which is enabled. For this demo, let's disable it. Now go to the storage section. Here you see 1024 GB, that is 1 TB. For eCPU compute model, the minimum required storage for ATP is 20 GB. You can change this to 20. So if you just put lower than 20 GB, you'll find there is a message there, right? So let it be 20 GB and let the storage auto scaling be disabled. Next, we see the backup retention. With eCPU compute model, you can set your backup retention to anything in the range of 1 to 60 days. Let it be for 7 days. So either you can put it here or you can type in here. Then set the credentials for the admin user. Let's fill the password. So this is the password for the database user admin. Next, the network access. We have 3 different types of network access. One is secure access from everywhere. This is accessing the database over the internet. Then if you are in public domain and you want to restrict access to certain IPs or VCN, you can choose this option. Okay. And if you want to have a private endpoint for your database access, then you can choose this option. If you choose secure access from allowed IPs and VCNs, you can provide the list of IPs. This can be a comma separated list of IPs. You can also add your own system IP. So you can click on add my IP address. Next, the private endpoint access only. There you need to provide the VCN. And for example, here we have VCN OU demo 1. and then provide a private subnet. As in here, you can provide private subnet. Let's go with the default, that is secure access from everywhere. Secure access from everywhere, for this kind of network access, it requires MTLS authentication. Then the license and Oracle Database Edition. So if you want to use POAL, you can choose that. For this demo, let's keep it license included. Here you provide the list of email ID of the contacts who would be notified in advance whenever there is a maintenance activity due to be performed. Next, you see there is a link show advanced option. Click on that. So here you see 5 different tabs. First one is encryption key. This is the key which will be used to encrypt your TD master key. Either it can be encrypted using Oracle managed key, which is the default one, or you can encrypt it using your own key. So for that, you have to choose encrypt using customer managed key, which may be in this tenancy or in a different tenancy. Okay. Next is around maintenance. So this is where you select your patch level, whether it should be regular or early patch level. Okay. Then we have management. Here you can set the character set and national character set for your database. So let this be the default one. Tools. These are the list of database tools which are integrated with your autonomous database. You can either enable it or disable it. You can do this right here by clicking on edit tools configuration, or you can enable or disable it even after provisioning. Tags. This is where you can use it to organize your resources. Either you can predefine tag namespace and then provide the tag key and its value, or else you can have a free-form tag where you can provide the tag key name and its value, like whether the database will be used for development or production. So you can provide an environment, and here the tag value could be dev, prod, whatever. So that's all you need to fill, and then click on create autonomous database. So right now you see the status is provisioning. You can skip the tour, or else if you would like to see, you can check this. Yes, our database has been provisioned. You can check the status of the database that is available. Let's check some details about this database. This is the name of our database, the workload type, and the license type is license included, and the version. Scroll down, you will see the resource allocation section. Here you see the compute model, what we see, right? So here compute auto scaling is disabled, and storage is 20 GB, and storage auto scaling is disabled. Okay, and other, these are the tools which has been enabled. Okay, so what we saw in the tool section, and right, you see this is the disaster recovery section where you see what is the role of the database. This is primary, you can see here, and the kind of disaster recovery mechanism which is set right now is backup based. Okay, so you can upgrade it to autonomous data guard. So under backup section, here we have the retention period of 7 days. The total backup storage, right now there is no backup, so no value here. So when was the last automatic backup? So there was no automatic backup which has happened, and also no long-term backup. If you had already scheduled the long-term backup, like weekly, monthly, or yearly, then you'll see when is the next long-term backup. If you want to schedule your long-term backup, click on the schedule link. You can provide the frequency, like how long you want to retain it, like minimum is 90 days and the maximum is 10 years, and what should be the schedule, whether you want to do monthly, weekly, or just once. So you can provide one time, this does not repeat, and when is the date and time. Okay, so let's cancel this right now. And then the network access, this is where we have chosen allow secure access from everywhere. So this doesn't require a access control list, so this is disabled. And MTLS authentication is required for allow secure access from everywhere network access type. Here is some details about the maintenance, like what is the patch label and when is the next maintenance window. And these are other services like DataSafe. This will provide you data security solution for your autonomous database, like where you can do the auditing or activity monitoring or discovering sensitive data or masking the sensitive data. All those operations you can do from DataSafe service. Okay, now let's check some of the tabs here. Database actions, these are all the tools which has been pre-integrated with autonomous database. This is for running SQL, and then we have the REST database service APIs which you can make call. Then database users, if you want to manage the database users, you can click on this. If you want to load data, and if you want to see what other tools you can use with Autonomous Database, which are pre-integrated, click on view all database actions. Then we have database connections. This is where you can download the wallet that can be used for MTLS authentication. Like you can provide the instance wallet and click on wallet. It will ask you to provide a secured password. You can provide that and click on download. Okay. So if you want to use TLS based authentication, you can just pick up this connection strings here by clicking on copy and use it in your configuration. Next, we have Performance Hub. This gives a similar look and feel, just like in Oracle Enterprise Manager. We have different tabs like ASH Analytics, SQL Monitoring, Average Active Sessions, ADDM, Workload, Logging Sessions. If you want to download AWR report, you can click on Report and then select AWR. It will ask you to provide the snapshots. Since this is a new database, we don't have any snapshots. So if you need, you can download the AWR report to do some analysis with respect to performance. Let's cancel it and close this tab. Now click on Manage Resource Allocation. So this is where you can increase the number of OCPUs or eCPUs depending upon which compute model you are chosen. So here we have selected the default value of 2. If you want, you can increase it. If you want to enable auto scaling, you can do this here. Similarly, for storage, you can increase the value and click on storage auto scaling if you want to do. And if you want to scale down, you can first perform the shrink operation before doing the scale down operation. Okay, so let's cancel it. And more actions, these are other actions what you can do with your Autonomous Database, like you can stop, restart, create a clone. If you are using Autonomous Data Guard, then you can perform a switchover. You can also update the network access. Right now we have secure access from everywhere. You can choose any of the other two. You can reset your administrator password. You can update the license. Then you can also set up auto start and stop schedule. If you want to change the TD master key encryption from Oracle managed to customer managed, if you want to rename the database or the display name, or if you want to move the resources to a different compartment, or even if you want to terminate. So this is all the different actions what you can take from the details page. On the left, there is a resources tab. Under that, you find few other information. There's the metrics window where you see the CPU utilization, storage utilization, execution count, sessions, running statement, queued statements. And then if you click on backups, you will see what are the currently existing backups. Okay, if you want to create long-term backup, you can click on create long-term backup. And then regarding encryption of a key, you click on key history. So here you are using Oracle managed key to encrypt your TD master key. That's what you see in the history. Disaster recovery, right now we have the backup based. That's why you see here is the default one. Refreshable clones, we don't have anything. And then if you have placed any work request, like here we created the work request, create Autonomous Database. So that's what you see here listed. Okay. And guided console tool, if you want, you can take that. So this is how you provision your Autonomous Database. Now let me show you how you can change the compute model during provisioning. So post provisioning, you won't be able to change the compute model. So that decision you need to take when you are provisioning Autonomous Database. Click on Autonomous Database. Let's get into the process to create Autonomous Database. Click on Create Autonomous Database. Right now the compute model which is default is eCPU. If you want to change the compute model, click on Change Compute Model. So here you see the default is eCPU. If you want to change to OCPU, this is the legacy compute model. You can click on this and save it. You'll see it has changed the compute model type to OCPU count, where the minimum required is 1, and even for the storage, the minimum required value is 1 TB. Okay, so let me cancel it. This is just to show you how you can change the compute model during provisioning. So that's a small demo on how you can create Autonomous Database in Oracle Cloud Infrastructure. I hope this was helpful. Thank you.
Hello everyone, let's see a demo on on how to access Autonomous Database that is hosted in a private subnet in Oracle Cloud Infrastructure from an external client over the public internet. This is how a reference architecture might look like. Here we have multiple availability domains, that is AD1, AD2, and AD3. And this is a regional VCN, which has multiple subnets, and our Autonomous Database is hosted in a private subnet with CIDR 10.5.1.0/24. And you have other applications which are present in a public subnet, like here 10.5.0.0/24. Here there are a few virtual machines and web servers, and you have a load balancer within that public subnet. And then there is a Bastion service which is created in another public subnet. You might be using other services like identity and access management, auditing, or object storage. And this is our client, which is SQL developer here. In order to access Oracle Autonomous Database in the private subnet, we are going to first set up a SSH tunnel from your client system to the Autonomous Database endpoint using a OCI Bastion service session. So what are the steps we are going to configure? First, we'll update the network access type of the Autonomous Database to private endpoint. At present, it is set to secure access from everywhere. We will update that to private endpoint access. Next, we'll create a Bastion service. It should be in the same VCN as the Autonomous Database, and it may be in the same subnet as your Autonomous Database or in a different subnet. In this case, we'll create the Bastion service to run in a public subnet. Following that, we'll have to create a network security group and add the ingress rules with the Bastion IP as the source and any open port. The port number can be the same port number which is open in your local system. Using the Bastion which we created, we'll create a port forwarding session to the Autonomous Database private endpoint. Next, we'll create a SSH tunnel in your local system using the Bastion session we created. Once the SSH tunnel has been set up from your local system, you can configure SQL Developer with the details of the Autonomous Database, and then you can connect to the database and perform some operation. Let's get into the demo environment and see how all the steps can be executed. I'm into the OCI console, and the region currently set is USC/1. Before we update the network access type for our Autonomous Database, let me show you what is the VCN which I have configured that will be used for updating the network access type of the Autonomous Database to private endpoint. Click on this menu icon, Networking, Virtual Cloud Networks. Make sure you are in your right compartment. I have set to OU Demo 1 here, and this is my VCN which I have already configured. The CIDR block range is 10.5.0.0/16. Click on this VCN link. I have two subnets here. One is a public subnet and the private subnet. This is the CIDR range for the private subnet, and this is the CIDR range for the public subnet. The public subnet I'll be using for creating the Bastion service, and I'll update the network access type of the Autonomous Database to this private subnet. Right now, there is no network security group. This is essential to be created first, as you would require this to be provided as an input when you are updating the network access type for your Autonomous Database. So click on Network Security Group. Click on Create Network Security Group. Let's give a name for it. Then click on Next. So ingress rules, we can skip this as of now. We'll add it later once we create the Bastion service. Click on Create. A network security group has been created, and right now there are no security rules. We'll add this later once the Bastion service is created. Let's navigate to our Autonomous Database instance and update the network access type. Click on this menu icon, Oracle Database, Autonomous Database. I'm in my compartment, OU Demo 1, and this is my database instance running. Click on this link. Currently, the status is available, and this is the details page of the Autonomous Database. You scroll down, you'll see the network section where the access type is set to allow secure access from everywhere. Let's update these to private endpoint. Click on More Actions, Update Network Access. So these are the different network access which are available for you to set up. Right now, we'll set it to private endpoint access only. So once you select this, you have to provide the VCN name. Click on this drop down. VCN 1 _ UDemo 1 is what we had set up. and the subnet is the private subnet which we are going to choose. Click on Show Advanced Options. If you want, you can set up a private IP address for your autonomous database within this private subnet, and you can also attach a hostname prefix for it. Network security group. This is a mandatory field what you must provide. Otherwise, you will receive an error. Let's see what kind of error we receive if we don't provide the network security group name. Click on Update. It will ask you to confirm the database name. Click on Confirm. And you can see there is a information which says the operation failed since the autonomous database private endpoint VCN OCID is not associated with the network security group. Okay, so let's cancel this and provide the name of the network security group. Click on Cancel and then select from the drop down OUATP_NSC. Now you can click on Update. It will again ask to confirm the database name. Just provide the database name and then click on Confirm. So this will change the status to updating, and it will update the network access type to private endpoint access only. The status is now available. Scroll down to the network section and you see a few more additions to the configuration details. The access type is virtual cloud network. What is the VCN name? What is the subnet name? And you can see it has assigned a private endpoint IP to your autonomous database. Copy this and put it into a notepad. We'll need this while creating the Bastion session. And then this is the name of the network security group. Public access is disabled. We have updated the network access type. We are going to create the Bastion service. Now let's go and create a Bastion service. Click on the menu icon, Identity and Security. Scroll down and click on the link Bastion. Right now there is no Bastion service running in this compartment. Let's create one. Click on Create Bastion. Give a name for this. And what is the target virtual cloud network? As I mentioned earlier, this should be in the same VCN as your autonomous database. Click on this drop down and you see VCN OU demo 1. And for target subnet, it can be the same private subnet which you selected while updating the network access type for the autonomous transaction processing database, or it can be a different subnet which must have access to the private subnet used for autonomous database. Click on this drop down. Let's select the public subnet in the same VCN, and you can enable FQDN support and SOX 5. For CIDR block allow list, since you are going to access the autonomous database from a client program over the public internet, the IP can be anything. So let's put it as 0.0.0.0/0. Click on New and then click on Create Bastion. This will take just few minutes to create the Bastion service. Let's wait for it to complete. A Bastion has been created. Click on this link. This is the detail space for your Bastion. Note the private endpoint IP address of the Bastion. Copy this IP into a notepad. This is the IP which will be used for setting up the ingress rule for the network security group. Let's go to the VCN and update the ingress rule for the network security group. Click on this menu icon, Networking, Virtual Cloud Networks. Click the name of the VCN. Scroll down, you'll find Network Security Group. Click on the name of the network security group. Scroll down under Security Rules, click on Add Rules. And the direction is Ingress. Source type is CIDR. For the source CIDR, put the IP of the Bastion what we copied. /32. The protocols, we can put it as TCP. For the source port range, let it be all. For the destination port range, we'll enter 1522, which is the port number for autonomous database. Then click on Add. Our ingress rule has been added. Let's now go and create a Bastion session. Click on the menu icon, Identity and Security. Scroll down to Bastion. Click on the link for the Bastion. Scroll down and click on Create Session. For session type, change it to SSH port forwarding session. Let the session name be as is. And for IP address, put the private endpoint IP address of the autonomous database. This we had copied earlier. This IP address. For port number, we'll put it 1522. This is the port number for the autonomous database. Scroll down. For SSH key, either you can generate a SSH key pair here, or you can reuse something which you had created earlier. I already have a key pair. Let me use that. Remember that you need to provide the SSH public key file. So this is my public key file. Click on Show Advanced option. Here you can set the session time to live, like how many hours or minutes you want to set. You can specify the number here, and minutes or hour you can choose here. So let's keep the default here. Click on Create Session. Our session is created and the state is active. Now we'll have to set up a SSH tunnel from your system to the autonomous database private endpoint. Click on this 3 dots. Click on Copy SSH command into our notepad. Replace the private key to the location where you had the file. For local port, this can be any of the port that is open on your local system. Here let's put 1522. This is the IP of the autonomous database and the listener port, so we don't have to change anything. So this is the complete command, what you need to run from command prompt. Let me replace this with the name of the private key file. Either you can give the absolute path of the file, or you can browse to the directory and just give the name of the file. Let's execute this from the command prompt and see if the SSH tunnel is running successfully. Copy this command. I'm already in the directory where my SSH keys are placed. I can just directly execute this command. My SSH session has got started, and towards the end you'll find some message like debug 1:plays. You might see network or any other message. Let's now move on to the next step of configuring the connection details of autonomous database in SQL Developer. Before configuring the connection details for autonomous database in SQL Developer, we need to first download the wallet and do some changes into the configuration files that will be used in SQL Developer. So first click on Database Connections to download the wallet. Under Download Client Credentials, let the wallet type be Instance Wallet. Click on Download Wallet. Provide a password to secure your zip file and click on Download. Since I've already downloaded, let's cancel this. Click on Close. Once you download the file, extract it. I've done it here already. This is the wallet file zip extract. 2 primary files we need to make change. One is sqlnet.ora and the other is tnsnames.ora. You can open both these files. I've already opened both these files. This is the sqlnet.ora and this is the tnsnames.ora. So here for directory, we need to provide the path for the extracted wallet file. Okay. And for tnsnames.ora, here you find the different service names like OUATP underscore high, low, medium, TP and TP urgent. Let's say we want to connect to high. So within that connection string for the host parameter, replace the host name to localhost. And save both these files. Click on Save. Click on Save. Okay, so these are the changes what you have done. And for connecting to the database, we'll use the JDBC connection string. It should be JDBC:/Oracle:/theme:@ the service name, that is OUATP underscore high, for which we made the host name change to localhost, $, TNS admin, then the path for the extracted wallet. You have to escape the backslashes with another backslash. I have already done the configuration in SQL Developer. Let me show you the properties of the connection. This is the SQL Developer GUI, and here is my connection name. Let me show you the properties. So the name is OUATP, the username is admin, and the corresponding password what you had set. I've saved the password. And under connection type, choose custom JDBC. Okay. And this is the same connection string, what I was showing you in the notepad. You can click on test. Connection test has failed. So what is the reason for that? This is because the SSH tunnel which we had set up from the client system has ended. You can check the status here. It has a exit status -1. You can just re-execute the statement. So this has started again. Let's test the database connection once more. So this time it's a success. You can save the connection and click on connect. The connection is established. You can run some command here. So the table got created. So this is the complete set of steps what you need to follow when you are connecting from an external client program like SQL Developer to Autonomous Database, which is having a private endpoint. I hope this was helpful. Thanks for watching.